Okay, looking at number 12, the following data are based on a survey taken by a consumer research firm. In this table, X is the number of televisions in a household, and the percent is the percentages of U.S. households that have that many televisions. This looks like a standard probability distribution to me, so let's check it to be sure that all of those probabilities add to 1. So this is a standard probability distribution. It's not binomial. And in part A, we're asked, what's the probability that a household selected at random has less than 3 televisions? So less than 3 would be 0 or 1 or 2. So I'm going to add those probabilities together. The probability of 0 plus the probability of 1 plus the probability of 2. 3% plus 11% plus 28%. 42% chance that a household selected at random has less than 3 TVs. In part B, what's the probability that a household selected at random has more than 4? The only option of more than 4 would be the option of 5 or more, which is 7%. In part C, we're asked to compute the expected value of this distribution. And since this is a regular probability distribution, the expected value is the sum of all x times p of x values. And I'm going to want to get out my calculator and look at the lists in order to do this. So first I'm going to clear my lists, and then I'm going to put my x values in L1. And the note on that problem told me to use 5 for 5 or more. And I'm going to put my p of x values in L2, and I'm going to make sure to convert those percents to decimals. Once I've got all that stuff in there, I'm going to go back to my home screen, and I'm going to do L1 times L2, and I'll store that in L3. And I'm going to make a note on my paper that this is what I did so that I'm showing my work. L1 are the x's, L2 are the p of x's. I did L1 times L2, I stored it in L3, and now I'm going to run 1-bar stats on L3. And I see that the sum of this list, which is what I'm looking for, is 2.67. So my expected value for the number of TVs in a given household is 2.67. I would expect a U.S. house to have approximately 2.67 TVs. Next, I'm going to compute the standard deviation sigma, and for a regular probability distribution, that's the square root of the sum of the quantity x minus mu squared times the p of x values. So again, L1 is x, L2 is p of x. L1 minus my expected value, 2.67, and I'm going to store that in L3 because we don't need what's in L3 anymore. That part of the formula, what I just did, was the x minus mu. Now I need to square it, so I'm going to go back and I'm going to take L3, square it, and I'm going to store it in L4. So this represents the x minus mu squared values. And now what I need to do is multiply those by p of x. So I'm going to take L4, multiply it by L2, and store that in L5. So I'm building the formula as I go using my lists. Now I can run 1-var stats on L5, and I see that the sum of L5 is 1.2811. So that would be my variance. To get my standard deviation sigma, I need to take the square root of that. And I want to take it to all the decimal places so that I don't get any rounding error. So my answer is about 1.13. The standard deviation of TVs in American households is about 1.13.